All right, this is our final part for you wannabe doctors, physicians, and you sports-minded like type people. So where do we see this torque stuff in the body? The answer is all over the flipping place. Okay, everywhere. So if we're looking at this bicep over here, so remember muscles can only contract. They can't. All they can do, the muscles contract. They get smaller. So all they muscles can do is pull on things. So go to the other way, you need a muscle over on this side that pulls, that wraps around and attaches to the arm from behind the elbow, that pulls it the other way. Whoops, went backwards. I went click by accident. That pulls it back the other way. Okay, that's how your arm works. If you can see this over here. So this muscle causes this to happen. Then to go the other way, I need this muscle to go that direction. Okay, so muscles can only clench up. So the way to go back, this one has to clench up to make it go back. So we have levers all over the place. So to make this thing go up, to lift this bowling ball, it's a 50 Newton ball, so that makes it like a 5 kilogram ball. So that's about a 10, 11 pound ball. So it's not a heavy ball, but there you go. So look where it's attached, guys. Attached to a tendon, muscle attached to the tendon, which attaches to the bone right over there. And if you noticed, so this distance from there, clear to, it must be, okay, let's look over here to the ball. So from the elbow joint, the fulcrum is 35 centimeters to the center of the ball. But to where the muscle attaches right over there, it's, so from there to there, okay, I see what they're doing. It's only 3 centimeters. Okay, 3 centimeters from there to there. So the fulcrum is actually right there on the elbow. So it's not your typical teeter-totter kind of thing, because this muscle right here, that's the counterclockwise torque. This ball is causing the clockwise motion this way. So if we're just holding the ball, we've got those two things. So pop quiz, guys, which is the greater force? The 50 newtons of the ball or the muscle pulling upwards? Well, guys, the muscle is on a much smaller lever arm. It's a much greater force. Okay, a much greater force. And so now we're going to solve for what that is. The reason we're going to solve for it because we know our lever distances. We know this lever distance for the muscle is only 3 centimeters, and it's 35 centimeters clear for that weight over there. So now we're going to set it up just like we've been setting everything else up so far. Okay, so here we go. Blah blah blah, there's the picture. So there we are. So we're at 50 newtons at a distance of 35 centimeters or 0.35 meters. Now the force of the muscle there is at 3 centimeters or 0.03 meters. Solving for the F, wait for it, drum roll please, 583 newtons. Woo! Hey, you guys might be saying, yeah, that seems big, Mr. Olson, but there's like 4.45 newtons for every pound. Guys, that's still, what, 140 pounds or 150 pounds? Still, that's a lot of force. And you guys, this is an 11-pound ball. So you can lift more than an 11-pound ball. So here's what happens sometimes. It doesn't happen very often, but it's an injury that has happened. Is that some people, they put such a big strain on their bodies and they're lifting and all kinds of things. So that's only 11 pounds. What if you went with 5 times that amount, 55 pounds, trying to curl 55 pounds? That's 5 times the amount, 5 times this amount. Now you're up into, remember, I said that's like 150 pounds. Well, times 5, well, now you're up to 700 some pounds of force between the tendon, the muscle, and this bone. What happens is sometimes the injury is the force is so great the tendon pulls the bone off of the bone. So the bone structurally is not strong enough to keep itself together, and the tendon actually literally pulls the bone off of the bone there, and it detaches and has to be reattached, and that takes a while to do, because these are some very, very large forces. And guys, it's not just the arm. Think about it, it's your leg is attached the same way. Our arms are attached like this, not to give us great forces that we can push on things, They are great forces on this, but what they give us is a great range of motion. So this muscle can't move very far, guys. These cells, they clench a little bit, they only move a little bit. This muscle only clenches a little bit, but because this is such a small distance and this is a large distance, it moves your arm through a very large distance like a catapult. So it makes it so you can't push really super hard on things, but it gives you a very great range of motion, which is great for throwing stuff, great for reaching for things and all kinds of motion. So these are very, very large forces on your body to make those things happen. And so on. So we have these in your arms, you have these in your legs, all kinds of places, but there are tremendous forces going on between your muscles, your bones, and whatnot. Hey, that's the end, guys. All right. Have a good one.